In this video, we discuss about the applications of concept of impulse. Application of impulse. In the previous video, we studied that impulse equals to force into time, and if the force is increased, if the time gets increased, then the force acting becomes less. So to decrease the force acting, we will have to increase the time. And the concept of impulse is, the first concept is, application is, a cricket player lowers his hand while catching a ball. A cricket player lowers his hand. A cricket player lowers his hands while catching a ball. So by lowering his hands, he increases the time interval. Therefore, less force exerts on his hands. A cricket player lowers his hands while catching a ball. By moving the hands backward, the cricket increases the time of catch. By moving the hand backward, the player increases the time. The player increases the time. By moving the hand backward, the player increases the time of catch due to the force exerted. Due to the force exerted on its hand. Force exerted on its hands becomes less. This is the reason in examination the question would be asked that why a cricket player lowers his hands while catching a ball. So the answer will be a cricket player lowers his hand while catching a ball because by moving the hand in backward, the player increases the time of catch. Increases the time of catch due to the force exerted on its hand becomes less. Second application, a person falling from a certain height receives more injuries. A person falling from a certain height receives more injuries. A person falling from a certain height receives more injuries when he falls on the cemented floor. When he falls on a cemented floor. when he falls on a cemented floor, then when he falls on a heap of sand, then when he falls on the heap of sands. When a person falls from a certain height, then when he falls on a cemented floor, then large force will be exerted by the man, and the man will receive the large force. And when he falls on the heap of sand, then less force receives. The man receives the less force when he falls on the heap of sands. Because when he falls on the heap of sands, he do not stop suddenly. He increases the time of stop. When the person falls on the heap of sands, he increases the time of stop. And due to the increase of the time of stop, a person receives less injuries. But when he falls on a cemented floor, then he can't increase the time of stop. And that's why the person receives more injuries when he falls on a cemented floor than when he falls on the heap of sands. Next application is automobiles are providing with sockets. Automobiles like car, bus, truck provided with sockets. Provided with sockets. Automobiles, cars, bus, truck provided with sockets because the socket increases the time of jerk. Because the socket increases the time of jerk. And due to this, an automobile receives less jerk or less force. Automobiles like cars, bus, trucks are provided with sockets because the socket increases the time of jerk. Socket increases the time of jerk, and due to increase of the time of jerk, an automobile receives less force. Buffers are provided between the bogies of trains. Buffers are provided between the bogies of trains. Buffers are provided between the bogies of trains because buffers decreases the force of impact. Because buffers decreases the force of impact. Because buffers decreases the force of impact by increasing the time interval. By increasing the time intervals. So these are the application of impulse, now the next topic which we discuss, that is Newton's third law of motion. Newton's third law. And the statement is, to every action there is equal and opposite reaction. To every action there is equal and opposite reaction. Equal and opposite reaction. Equal in magnitude and opposite in direction. Equal in magnitude and opposite in direction. Means action is equals to minus of reaction. This equal to sign gives that the reaction is equal and opposite. Minus sign shows that the reaction is always opposite. Suppose there are two bodies, A and B. So both exerts force on each other. This is the force FAB. FAB means force on a body A due to the body B. And this is the force FBA. Force exerted on body B by body A. So both exerts force on each other. And these two force is given by FAB vector equals to minus of FBA vector. These two forces must be equal in magnitude and they are opposite in direction. The few important points. Action and reaction. Action and reaction always acts on two different bodies. On two different bodies. Action and reaction always acts on two different bodies. And the force of action and reaction do not cancel each other. The force of action and reaction do not cancel each other. Because they act on different bodies. Because they act on different bodies. Since the action and reaction acts on different bodies, therefore, being equal in magnitude, they do not cancel each other because they act on different bodies. If action and reaction acts on the same body and the magnitude are equal, then they get cancelled each other. But when action and reaction are acting on two different bodies, then they do not cancel each other. No action, no any action occurs in the absence of reaction. No any action occurs in the absence of reaction. No any action occurs in the absence of reaction. So this is about Newton's third law. The statement is to every action there is equal and opposite reactions, equal in magnitude and opposite in direction. Action is equals to minus of reaction. An important point about this that action and reaction always acts on two different bodies, and the force of action and reaction do not cancel each other because they act on different bodies, and no any action occurs in the absence of reaction. In the absence of reaction, and if there are two bodies A and B, then FAB means force on body A due to the body B. Force on A due to B. And FBA means force on body B due to the body A. Now the next topic which we discuss, illustrations of Newton's third law. Illustrations of Newton's third law. First is book kept on a table. Book kept on a table. There is a table and a book is placed on the table. So book exerts a force in the downward direction. Book exerts a force in the downward direction in the form of weight W. Because weight of a body acting vertically downward, book exerts a force in downward direction in terms of weight of the body, and table exerts equal and opposite force on the book. Table exerts equal and opposite force on the book in terms of reaction R. So R is the normal reaction. R is called normal reaction because this reaction acting vertically upward, 90 degree from the book. So when a book is kept on a table, then book exerts a downward action force on a table equal to its own weight. Book kept on a table, then book exerts a downward force on a table in terms of action. In terms of action, book exerts a downward force on a table in terms of action equal to the weight of the book, equal to the weight of book, equal to the weight of book. Means the force exerted on the table by the book is called force of action, and which is the action force is equals to the weight of book W, and W equals to m into g, mass into acceleration due to gravity. And according to Newton's third law, and according to Newton's third law, book according to Newton's third law, table also exert a force that is called reaction in upward direction. Table exerts a force in terms of reaction on the book in upward direction, and these two forces, if the book is in equilibrium, then R equals to minus of W. Action equals to reaction. R equals to minus W. Minus sign shows that reaction is in opposite direction. The reaction acts in a opposite direction. The next application is while walking. While walking, we press the earth in backward direction. While walking, we press the earth in backward direction. While walking, we press the earth in backward direction by our feet. That is called force of action. That is called action. When we press the earth in backward direction by our feet, we are doing action on the earth, and action pulls our feet in forward direction, and earth pulls our feet. That is reaction in forward direction. Due to which we are able to walk on the earth. Due to which we are able to walk on the earth. So these are the illustrations of Newton's third law of motion. The first was book kept on a table, then book exerts the force in terms of action in downward direction on a table, and table exerts a force in upward direction in terms of reaction, and while walking we press the earth in backward direction by our feet, and that force is called action, and earth also pulls our feet, means reaction in the forward direction, and due to which we are able to walk on the earth.